This is Professor Kim Nelson with the Jewelry Design Department of the Fashion Institute of Technology. Another tutorial in our series of tutorials for basic Rhino CAD modeling. Excuse me. This tutorial is going to talk about doing a maquette or a 3D sketch in Rhino. In class I worked with student samples. Here I'm just going to use a heart, a simple form to start working with. Begin by drawing my heart using history and a mirror down the center. And rebuild. And adjust my heart a little bit. Now, for some reason, I have lost history over here, so I will go ahead and remirror. One of those trims must have gone the wrong direction. I must have trimmed the, or fillets. I must have filleted the child curve instead of the parent. Okay, that's a good place to start. I'm going to mirror, join this and mirror it, and offset it. Offsetting a heart is tricky because actually it's the inward heart that you want. So I'm going to offset it going outward. That'll be easier. So basically I have a heart with a border. I would like the overall size of this object to be 20 millimeters. So circle, and I want to be able to do a orient command. To do that I need an actual top elevation here right in the middle. The way I'm going to get that is straight line, tangent, two curves. There, that middle point of that tangent curve will give me the overall maximum height, and the point will give me the maximum bottom of the shape, top and bottom. So take these and do my orient, copy, no, scale, yes, 3D is fine. Okay, apparently, oh, my bad, sorry. Okay, again. Change the shortcut for my object snaps and forgot that I'd done that. Okay, 3D, and I want to go from mid and end to quad and quad. There. That'll work. Okay, I'm going to draw a side view for this. It's going to be a very approximate side view. Now the end is easy, right here. The back of the piece is easy. I'll put it roughly there. The overall thickness for the piece is easy. I'm going to put it about there. Maybe a little more shallow than that. Overall height is going to be tricky once again because it's hard to get an actual dimension off of here. So I'll do the same thing I did before. Line, tangent, two curves, and then I'll just do a fillet and another fillet and repeat. So this will function as my more or less side view of this object for the purpose of our sketches. Going into perspective viewport, I'm going to rotate this so that it is standing upright, because I want to put it in a position. What I'm going to try and do here is to turn this upward and bring it into the center so I can use it as a direct reference for my maquette. So the first step is to rotate it from the front view and snap, hold shift key, and then to bring it over I'm going to go to the right C-plane and I'm just going to project this to C-plane. Delete input, yes, and that throws it onto that C-plane, which is right in the middle of my drawing. Okay, so I've got everything the way I want it, except for the colors are reversed from what I would normally do. Normally red is my side view. Okay, I'm going to begin maquetting. Most obvious maquetting technique is an extrusion. Just extruding straight. Remember, extrusions run perpendicular from the current C-plane, so this would extrude that way off of the right C-plane, and this will extrude this way off the top C-plane. I do want a solid, so solid yes. And I'll just grab the end point of my side view. And there's my basic heart. Now I do have a second heart forming here. I'm going to extrude that as well, the same way. And I'm going to non-uniform scale my outer heart. I'll just do it from 0. No change there, so 1. No change there, so 1. And here, I'll scale it down until I get a nice difference in elevation. And that would be one possible way of making a maquette for a piece of jewelry that at least matches the top view. The side view, I've put in an extra elevation that wasn't there. Another option would be to move this up and solid difference the center out. Another form, this time it would actually coincide with the side view because you wouldn't see that insert. Both of these things are typical ways of making a maquette using a simple extrusion. I'm going to go ahead and make the extrusion a little more sophisticated through the use of fillets. Okay, so I'm going to fillet this outside edge, and I'm going to fillet it. Remember, the way to figure a fillet is to decipher what the distance is that you're working with, and then not go beyond half of that if you're going to fillet both sides. So in this case, analyze distance. I have basically 1.9. That's really not accurate because it's at an oblique angle to the two curves. To get it accurate, I would need to do this. And we'll see what the difference is. Length of that curve is 1.865, so 1.9 is fine. So I can fill it at 0.8. Or just under 0.8. So solid fillet edge, and I'm going to do it 1.8 would actually be 0.9, so I'll do 0.8. Now you can see I have separate surfaces here. That means that for some reason, likely due to the offset, Rhino put a poly curve here, which gave me a poly surface. That could lead to trouble, but no, we're okay. So I have that filleted. And I could fillet this one as well. Remember, we discussed fillets in class, how if it's more than a 90 degree, you're probably going to end up with a problem. It's very likely the fillet will fail here. but it didn't. It worked out just fine. So this would be another way of creating a maquette for this piece. Okay. Let's talk about using pipes. I already know this is 1.9 roughly, so if I offset this curve, hold on one second. Okay, gotta take a little break there, hope we're alright. Okay, so I'm going to offset this, let's make it 0.9. See, let's make it 1 millimeter. Okay, now I know from that last offset that I ended up with a fragmented curve, a poly curve, with more than 2 segments. I only want 2 segments here for a pipe, so I'm going to explode this and see what I have. See, I have 6. That is not good. I'm going to extract away pieces from that exploded curve until I just have 1/2 that I want. Join that together. Delete these. Going to mirror with history, and I'm going to rebuild. The 4.9 is pretty good. There's a little variation. I'll increase the point count to 13. Yeah, that made it very tight. Okay. Now I can join these two together and pipe. So I'm going to pipe 2 millimeters in diameter because I offset 1, and that should give me a little bit of an overlap, which is what I'm looking for. Diameter 2. Okay, I did that with history. Gonna go look at my top view. That's pretty good. I am not going to complain about that at all. So that gives me a pretty good pipe. Of course, it's sitting, since the pipe was on the ground, it's sitting in the middle of the bottom edge of my piece, which I do not want. Go to my vertical C-plane, move my parent curve up, and the pipe will follow. I'm going to move it up until my piece is kind of hanging out the bottom a little bit. That's good. Okay. Going to do a cutting plane. Remember, the cutting plane is perpendicular from the current C-plane. In this case it's front, so it'll cut straight out from the front C-plane. Grab the end of that curve, pull horizontal. That centers that cutting plane right in the middle of my pipe. Trim the bottom of the pipe away. Extract the border from this. There it is, those 2 borders. Extrude those straight down. To the end snap. I can delete those curves. Join these together. And I can cap. If I wanted to, I could Boolean union. And you can see how that resulted in one open contiguous shell. Okay, so I'll undo the Boolean. So that's using a pipe to get what I want here. I'm going to do the same thing now for the center. I'll go ahead and hide this cake, in effect, that I extruded. I'm going to grab my inside curve and I am going to offset it 2 millimeters, or in this case actually 1 millimeter. So there's my 1 millimeter offset. Once again, I want to double check for curve integrity. I only want two. I want a poly curve, but I want it only made of two curves, left and right. See, it's given me 4. So offsets will often do that. Okay, so I'm going to join those two pieces together. Throw this part away, and I actually think I may offset it further. So I'm going to go ahead and rebuild this. Yeah, that's fine. I'm going to offset it even further. Going to offset it on another 0.5 millimeter. Okay, what's going to happen from doing that is it's not going to reach into the center anymore. That's okay. I'm going to mirror it over with history. I'm going to explode to see if it made two pieces. Nope, it's a single. That's good. I'm going to do a fillet curve to bring those two together. Now I know that that's a separate curve. If I explode that, I have two segments now. So I'm going to rebuild this. Our favorite 13. I'll go ahead and delete this the other side and just record history and mirror it again. And I will trim off this overlap, using the child to trim the parent so that the parent updates the child automatically. Okay. Now I want to pipe these, so I will join them together, which will break history. Going to pipe with 3 millimeters in diameter. Okay, take a look at my top, see how it's obeying my drawing. It looks pretty good. Okay, alright. Going to move my curve up. Go to the right view. Move the parent curve up until the top of my pipe comes close to the elevation I want. A little below. Okay? I'm going to project this center line from my pipe up onto the pipe itself. It's going to project straight perpendicular from the C-plane, as if a lantern were underneath it and projecting up onto a movie screen or a shadow puppet type of arrangement. So here we go. It gives me 2 because in the projection it would intersect with that pipe both on the bottom and on top. Going to extract, going to click and deselect the one I want to keep, and then delete the other. I'm going to use this curve. Actually, I'm going to leave them both. I'm going to use these two curves to trim away the inside of the pipe. Just like that. I am going to use a cutting plane to cut off the bottom of my pipe, just like I did for the outside. So I need my front C-plane active. The right C-plane would have also worked. I need a vertical C-plane. Cutting plane, snap to the end, hold Shift key, pull straight to the right or left, except for I had the wrong thing selected. Cutting plane you have to have what you wanted to cut selected, and I had the curve rather than the pipe. Trim off the bottom of the pipe. 2 steps left. One of them is going to be to put a patch on the top here. Surface, patch, the duct tape of Rhino. I'm going to try and let it maintain tangency to see what I get. I'll hit preview. That's fine. Join. And then I'm going to extrude this shape. So I will duplicate its border and extrude straight down. I just want it to be plenty long. Join these two together. Turn back on the dark blue layer. So there's the pipe I used to make the border, and I've used a pipe to make the inside offset. Now I will go to the right view and finish moving this, just because using the patch I might have gotten a bit of a swell there, and I wanted to make sure it was accurate. With the patch surface in place, I can make a more accurate judgment. Okay. I'm going to do a cutting plane from the bottom edge here. Could have also just used 0 and that would have worked. I can trim this off here and then trim off the remainder of that and join the two together. I could have also used cat planar holes. I probably could have done a Boolean difference for that matter. And speaking of Booleans, once again, if I wished, I could likely Boolean union these without any difficulty, resulting in one contiguous shell on the inside. Okay, so there's another way, using pipes, to create my heart. Slightly different effect. Okay, hide that, turn that off, delete this. Okay, the next method I can use a revolve command. So I'm going to offset once again. And this time I want to offset as far as I can and still have a reasonable chance of success. Now that doesn't look like a heart anymore, but it is useful to me. Go into a vertical C-plane. Draw a curve straight up from the point. Holding Shift. Borrow a copy of this curve. I can't pull in this direction because I'm in the front C-plane, so go back down to top. There we go. And I'll copy this again. Just redraw that curve. So I have those. I'm going to go ahead and move this curve down and trim this curve away. I'm going to do a blend curve, adjustable. And I'll adjust the points. Holding Shift key so I have a symmetrical adjustment. Then letting go of Shift key in case I want to sweeten that a little bit. Okay, there's my section. Okay, I need to establish a vertical C-plane again, so I'll use my favorite front. And I'll begin the command. Revolve would normally take this curve, ask me for revolve axis, which I'll put in the 0, straight up and down, angle 0, finished angle 360, and that would be my revolve. Revolve is like a lathe, it can only make circular forms. However, rail revolve is a different animal. If I right click on this command It'll ask me for a profile curve, which is my section. It'll ask me for my rail, which is the shape of my heart. And the same thing, start of revolve axis. I'm finished with revolve axis. However, I've made a mistake. Hang on, I need to back up a little bit. I did not want this to be from the border. I wanted it to be from here. So, minor adjustment. It actually looks pretty good as it is. Okay. Same thing holds true. If I took this section and did a rail revolve around 0, I would get a circular form. Doing rail revolve, and I can record history with this if I choose. Select my profile, which is my cross section, select my rail, and start of axis is 0, end of axis is here. And that will take that cross section and bring it all the way around the shape. The last thing for me to do would be to patch the center. Looks good. And I can cap the back of that, bring back my border, and there's another way to maquette that heart form. Okay? And lastly, we'll cover the most sophisticated method for doing this. Oh, by the way, I'll just double check that my Boolean will work with this. And it did. Okay. By the way, I want you to notice something in all of these maquettes. I have a crease. I'll emap it so it's more visible. I have a crease at the point and a crease at the cleft. The only way to avoid that would be to take the thickness down to 0 at those corners, like in a cone arrangement, or to round the point or the cleft. Okay? For a maquette, I'm not going to go into that trouble. I could, but I'm not going to. There's no reason to. Okay? So, our last way of doing this project. I'm going to pick my center heart shape, going to do a planar surface, and then I'm going to untrim that planar surface. Surface, Edit Tools, Untrim All. It should give me a little clearance, which it did, so this is perfect as it is. Okay? I am going to move these two out of the way. I am going to make a copy of this with history using grid snap back into the center. I want to rebuild this so that I have enough points to do interesting things. I like my point count to be an odd number, so I have a center line. So I'm going to do 9 and 9. So F5, I'm going to make this 9 by 9. And for a surface, I'm comfortable with 3 and 3. It actually gives me pretty good, a little better control. You'll see that this surface updated automatically. If I move this, that moves along. Now I'm going to flow along surface with history, base surface, target surface. And there I have a copy of my object. Now, what I would like to have happen is for me to be able to turn on the points of this object, adjust some points, and have the curve update automatically, which it did. Okay? Sometimes it won't. If that ever happens and it doesn't, undo, move just one point. It doesn't have to be hardly anything. Redo the transform, and then if you want to, put the original point back where it was using project to C-plane or any other method you want, and then it will work just fine. It's just sometimes Rhino, if it's the exact same surface math, which is what we want for a lack of distortion, but sometimes that's confusing for Rhino. You do a flow along surface and with history, and it just doesn't make the leap. But in this case it did, so in the interest of time I will keep on going. So, as I discussed in class, I can now modify this surface in several ways and have this curve update along with it. It's important to have good selection tools when you're control point editing. The most important one's on your Select tab. It's the lassoed points. We're not going to actually use lasso points. We're going to cascade the lasso points toolbar. It's these two we want, Select U and Select V. If I hit Select V, it grabbed that center row all the way down. Now, I had a student in class, I've been saying for quite some time, that there's no consistent logic in how Rhino assigns U and V. So you just try. But I had a student last week say, isn't V always going in the Y direction and U always going in the X? So X always horizontal, Y always vertical, or V always vertical. And it seems to be. Select V would be vertical. Select U would be horizontal. So, okay, so hopefully that remains consistent. What I want to do with this is I would like to dome it up. So I will start doing that. And I'll start making the dome by grabbing all of the points logically inside of the heart border. That one's really close to being inside the heart border, but not quite, so I'm going to leave it out. Okay. I'm going to use gumball. Grab my up arrow and pull. And you'll see that the curve updated to go along with me. I'm going to deselect the first row of points, moving inward from the border. Hate that about Rhino. The gumball always overlaps things you want to see. So I have that. I'll move that up a little more. And I'll remove the next row. And of course the gumball is perfectly in my way again. Okay. I don't know why I have a selection dot here. I shouldn't, because this point is not selected. Right now what I should have selected should be this series of 9 dots. And in theory that should not extend over, but okay. Looks like it's alright now. Display glitch. Elevate those up. And now the only thing I want to elevate is the center point. And that'll give me a soft dome sort of feeling. Okay. Next thing I want to do is I want to drop that center line. So I'm going to grab that whole center seam, and I'm going to pull it down. Okay, and I would like it to have a little more sharpness than that, so I'm going to go to my edit menu, my control points, sub flyout. I'm going to insert knot, select my surface. I don't want it to go that way, so I'll just hit T for toggle. I want it to go this way, and I want it to be symmetrical. And I want to bring these 2 points, these 2 rows, really close in. Okay. So you're not going to see any change in the surface. But now that I have all 3 of these, if I move them down, I'm going to get a little crisper line in the bottom. And especially actually if I lift these 2 on the side out just a little bit. Now you can see I'm getting a sharper crease down in the center. If I want an even sharper crease, insert a knot, symmetry yes, and that's even closer. So I can grab these 2, lift them up a little, grab the one in the center, move it down, and now I have a pretty sharp, crisp thing. I want to smooth this out a bit, so I'll grab those 2. This is where the symmetry in the center line, using an odd number of points, is very helpful, because I can keep my modeling symmetrical. These can come down a little bit. And I'll still have a nice sharp point. So I've got that where I want it. Okay. Now let's say I want to drop these side wings a little bit. So I'll just go ahead and grab the whole row, both sides. Drop those down. Okay. That might be a little much. Maybe I only do want 3 on each side. You get the idea. I'm able to play with this and get, some interesting results. Grab the 2 outer rows, move them up. And you can see I have that kind of wave effect. That's fine. Now I want to do the same thing that I've been doing before. I want to move this up so that it's my elevation. So bring back my right hand, my right curve. I only want to move the surface. I can use my gumball if I want to. By moving the surface, the lines will jump up to match. I can go to my right view and I can pull this up. I'm going to have it kind of average the height because I have lower and higher. Something like that. Now, I can use this curve, turn off gumball, to trim that surface. Returning to my top C-plane, I have a couple of choices. I can extrude this straight down and cut it off, or I can drop this straight down and extrude it up. I'm going to drop it straight down. So I'm going to project to C-plane. Delete input object, yes. Extrude it straight back up. And then trim. I'm going to fillet my edge. Try that 0.8, see what I get. Once again, very likely to get a failure right here. Yes. Okay. That does not surprise me. So, let's say, now I can try going to a smaller number. We'll try that just for fun, 0.6. I'm having the same exact problem. Okay. Now, I'm a little concerned because I was going to show you how to fight this filleting, but with this dip in the middle, I think it's the fast changing curvature also that's causing a problem. So I'm going to show you another way of doing a fillet, okay, as such. I'm going to undo my join, duplicate my edge. I'm going to put a pipe around that. Diameter of 2. Okay, not successful. Not successful at all. Okay, here's where the tutorial gets long. Bear with me. Whenever something fails in Rhino, it's because the math is too complicated. So I'm going to simplify the math. I'm going to explode this. And there they are, 4 segments. I didn't want 4, I wanted 2. So I know there is something wild going on here. And there it is. There was a little very slight, can't zoom in enough, the camera won't let me, so I'm going to zoom window, drag a little window. Okay, that's fine. I'm going to join that together. Now there's just no way that that is going to pipe well. It has to be a single curve, not a poly curve, for one thing, so I'll rebuild it. And 13 points is going to lose some of that shape. I don't care. I'm good with that. I'll delete the other side for now. I'm going to pipe. And now it works. Going to explode my pipe. Should be 3 surfaces. The pipe and the 2 end caps. There should only be 3 surfaces because I rebuilt that curve into a single curve. 3 surfaces. Hold down Control key. Deselect what I want to keep, the pipe. Delete the caps. I'm going to extend my pipe. Extend surface. And I want to extend it 1 millimeter. Same thing here. Going to do a cutting surface, cutting plane from 0, just so I have a nice clean edge, and to tell if I have a nice clean edge. On the bottom I do, but you can see at the top 1 millimeter wasn't enough, so I'm going to extend surface again. Now it's enough. Trim these away. Mirror. Join. Close poly surface. You can tell by the way it shimmied, it flashed. Bring back my block of surface here. Go into wireframe. Select my pipe. Trim. Trim off the edge of the top surface and the outside edge of the top surface, the top edge of the poly extrusion, poly surface. do a blend surface. Just for half the piece. Okay, you can see that I'm getting some very strange math there that I don't even want to contemplate. I'll try adjusting the sections to see if I can get something more reasonable. Okay, let's see what we get. Let's go to tangency instead of curvature. Remember, curvature goes in quite a ways. Yeah, see the strange surface I'm getting here? I don't love that. It's also strange there. I'm going to go ahead and live with it for a minute. It failed to make the surface. Okay. For a maquette, guys, I would have just called it quits at this point and let it be blocky on the corner. But I will show you what we can do in this case. Toggle. I'm extracting an isocurve. End snap to grab it at the end. This is reference geometry, nothing more. I'm going to do a blend curve. Actually, I want an adjustable. And the edge here. I like it. I like it. Okay. This is a suite, guys. This is for really a finished surfacing tool that I'm about to do. But it'll be a good preview for what's coming at you next semester. Sweeps use rails and cross sections. I'm going to do this two ways. The first way I'm going to do it is going to be a bi-rail sweep, 2 rails. Rail, rail, section, section, enter. That's fine. I can hit OK, mirror it over, join these together, and I have a pretty good example of what I want. I'm going to copy that out for a minute and then undo. I'm going to resurface these using Surface from Curve Network. Surface from Curve Network allows the command to pull tangency, flow information from other surfaces, helping you to keep it smooth. So we'll do the same thing. Okay. Select curves and network. You want to select rails then sections. Surface from Curve Network can have an unlimited number of rails and sections, but we're going to use the same arrangement we used before. And you'll see a dialog that pops up, and it says tangency, tangency. Wherever it can have a tangency, a surface edge to pull information from, it will give you a tangency or curvature option. You can see that I can't get tangency for A or for C. It's because they are not surfaces, they're curves. But I can get it for B or D. Now I could set B and D down to position. If I do that, it's not going to take any information off those edges, and it will give me a situation, a surface very similar to what the bi-rail sweep gave me. If I do this, it's going to copy the reference the surface information. So I'll hit OK. Slightly different surface. Mirror that over. Join. Okay. I'm going to paste back in the first one I did. And then I'll emap the two so that you can see the difference. Then there may not be a difference. usually there will be. You can see a pretty clear edge here, especially down in here, the way that bi-rail sweep handled that. You can see that with surface from curve network, less so. Still some strange things happening down in here. That's really a display. It's not really in the model. That's in the display. I believe. Yeah, if I go into shade mode, you can see that it's really, there is a seam there, but the strange fracturing you see are meshes on the surface, which if I set the surface mesh higher to smooth and slower and hit the render shade again, there won't be any of those in there. Okay, so anyway, comparable. Okay, this is a little crisper, a little more mechanical. This is a little softer. Either one would be fine. All right. So bring back my border. Now my border now has some issues because it's static, whereas this flows up and down. But it gives you a good idea how to use those different commands. So in summary, I used let's unhide some things. A simple extrusion with a cap, a revolve, sorry, simple extrusion, not with a cap, simple extrusion with a fillet, a revolve command, a rail revolve with a patch, a pipe with an extrusion and a patch, and a flow along surface with control point editing. Okay, so and this I have done a couple of different ways. One was using the pipe. The other, I don't think I kept it, was just a simple extrusion. No, I didn't hang on to that. Okay, so anyway, that should do for now. Please explore these techniques and use them to do the maquette for your Talisman project. Thanks, and I'll see you next week.